Good morning, everybody. John Grimsmo here. It is currently Saturday morning, 6:15 a.m. I've been here since 5 a.m. prototyping, having a blast. I am working on my new spinner prototype. These things are surprisingly fun. I've seen them take off all over Instagram, all over YouTube. I had to jump in, I had to play with one, I had to try to make one because that's the Grimsmo way. I'm really having fun with this thing. So the first bearing that I used, I went to my local bearing supply store and I just picked up, I forget if it was NSK or NTK, kind of an off-the-shelf bearing. It was grease filled. I took the seals off, I cleaned it with acetone, and then I put it in the spinner, and I thought it felt pretty good. But even with a really hard spin, I can only get it to spin for about 30 seconds, which is not impressive. I mean, it feels fine. It feels a little sluggish. The other thing I don't really like about it is there's quite a bit of play in the bearing. So as you spin it fast and as you wobble it side to side, you can really feel the vibration and feel the wobble. And you lose a ton of speed just by moving it over like that. So I got these really awesome bearings in yesterday, playing with our new spinner design, and I just got some new bearings in from Boca Bearings. They got a great website. These are the ones I got. They're very small. And we're testing the spin rate of them. Where'd that one you have go? Can you do it again?
Oh, it fell off.
So we just shoved it onto an end mill, and Eric found out that he's able to actually just spin the end mill, and the end mill keeps going with no outside weight, no centrifugal weight. I mean, these things are super free spinning. They have a little bit of play in them, which is kind of annoying, but maybe that's just what bearings have to do. That's pretty impressive. Very cool. So we're gonna put it together. I gotta make a new one of these with slightly different design to fit these new small bearings. But to get the thickness that I want, 1/8 of an inch, this is the size that they had. Ceramic balls on the inside, very high tolerance, ABEX 7. Looking forward to it. We've got the Mori running the spinner body right now. It's making it sort of like this guy out of a sheet of scrap titanium that I have. I think it's just doing the last chamfer right now. Chamfering a couple of the holes. Turn the coolant off. Let's get in there. And we're done. See how it worked. So last time I nested 2 pieces in one material. For this one, I didn't care. I just cleared away all the extra material. This is my my spinner body. The new bearings are quite a bit smaller than the old ones, so there's some unnecessary meat in there. No big deal. That looks beautiful. So now I gotta check the hole dimensions, see if I have to open them up a little bit more, get that end mill diameter just perfect. Because I want that bearing to push in there. I'm using a flanged bearing, which I'm hoping will allow me to press it down and keep it, you know, keep the height of the bearing exactly where I want it, so it's not too high, not too low. Because I'm using 1/8 inch thick. You know, I'm trying to make it 1/8 inch thick, and to get a bearing 1/8 inch thick, 1/8 inch thick, it's got to be pretty small. If it's thicker and doesn't have a flange, then it could stick out differently on either side. And then your press fit has to be perfect, and a lot of variables. So you try to minimize everything. So today, hopefully, I'll get that bearing pressed in, and then I want to make some buttons, some really nice, about this diameter onto here, because I'm using a pivot right now, a Norseman pivot. And while it's cool, it's too small. It's really awkward to hold on to. And it pivots too easily in your fingers, and you know, that is not the Grimsmo way. Now measuring with the calipers like this is not the most accurate way to do it, but it's going to get me close. Ideally I'd use pin gauges, but I don't have a 1/2 inch pin gauge set. Or you have some inside micrometers. I don't have that either. It's looking like the outside for the weights is 1 thou small, which is perfect. Should be able to press that in. Again, this bearing, the Boca bearing, is ridiculously impressive. I can spin this end mill. It's got no mass on the outside, it's all on the inside, and it's still spinning. This guy spins for as long as this guy does, about 32, 35 seconds. Just with a quick hand spin like this. It's super duper impressive. I can't wait to get this thing inside of a spinner. So to design this spinner, I'm using a program called Autodesk's Fusion 360 that I used to design all my stuff. And they came out with a new feature called Create a Branch. Now if you see here, I have one called Master, one called Grimsmo bearings, and one called Boca Orange bearings. So basically, the first design that I came out with, it's like this folder of all the parts. My bearing, store-bought bearings, the spinner thing, and then if I create a branch, it like copies all that and keeps it, and then makes a whole new folder that I can start working in. So when I changed from one kind of bearing design, but I wanted to keep that, I can branch the whole thing into a new design, use the Boca bearing, change all these diameters and everything, and have it still have the old setup that I can go back to. And then at the end, theoretically, I can merge them together back into one file when I have my perfect solid choice. I haven't tried the actual merge thing yet, but to have the branch is pretty sweet, because here is where my bearing will fit. Go into the model environment. That is the bearing right there. No, that's not the one. This one. So instead of putting a corner radius in there, I just put a little clearance. Should work fine. The section view analysis is super duper crazy handy. I use this all the time. And then if I go into my Grimsmo bearing folder, this is where I spent a crazy amount of time and actually designed and made the bearings that we use in our knives. I made a slightly variant version of them to use in the spinners with only 5 balls instead of 10, a little bit smaller radius. And I actually made these insane hardened washers on my Nakamura lathe. Come on. So this is made from 17.4 pH stainless steel at 45 Rockwell, which is hard. On the lathe, I took a ball end mill and I rotated the bearing into it to create the groove. And then I made, it's hard to show. It's in the lathe right now, so I don't actually show it. But I made these bearing press tools that will be in a shaft, if I can find the rest of it. I'm not sure where I put it. Essentially, this is mounted into an arbor, and then it'll press actual steel ball bearings into the thing, rotate it, so you're rolling a race onto there. So it's not just end mill chatter, it's actually rolled balls onto there. So my design, as you can see here, incorporates so knife bearing, you can see it highlighted. That guy and that guy are my 2 knife bearings, and then 4 bearing races are what I just showed you right there. Kind of overly complicated, definitely Grimsmo. I just wanted to see if I could do it, and in the end it took a lot more time than I thought it would. But I'm so impressed with the Boca bearings. I don't even know if I'll follow through with this project, you know, using my own bearings. I might, but I don't know. But this is what my button design, this is what the whole thing is going to look like in the end. I've got a little bit more detail I want to put around the outside of these guys. Definitely want to put Grimsmo engravings, you know, the Viking head somewhere. And yeah, I might even engrave around the outside. I'm not quite sure. Text around the outside like that. That'd be pretty cool. Haven't quite figured it out yet. But hopefully today I've got another 3 hours here before I am destined to be home by 10 o'clock. It's my son's 4th birthday today. I'm very excited about that. So I get the morning off to work, off from home to work, and get some good work done. Now I'm going under the assumption, and I think I'm right, that when you press a bearing into a bore, if the bore is too small, yes, you can press the bearing in, you can shove it in. But I think, especially such a small bearing with such tight tolerances, it's going to shrink the outside race of the bearing. So if I make too tight of a press fit, the bearing race on the outside might get a little bit smaller, the bearings might get a little bit tighter in there, and you might lose all that smoothness. So not too tight, not too loose, and we're talking about less than 1/1000th of an inch here. So according to the measuring like this with these calipers, the hole is 1/1000th smaller than the bearing is. I think I'm going to open it up a little bit more. If I have to use glue for this prototype, I'm not against that. Just a quick little dab to keep it in there. So I'm just going to kiss the hole again and open it up just a tiny bit. As a matter of fact, what we'll do is we'll run the same exact tool path, no coolant so we can see any dust forming, and usually running the same tool path again will just create a little bit of dust. It might just skim the outside just a little bit without actually opening it up more in the program. Find our program. This is our program name. Temp. I usually just mash the keyboard when I'm doing a temp program. Turn the feed down because I'm paying attention to the camera, not to the computer, which is not the best way to do this, but almost forgot to turn the coolant off. If I hold this button for a few seconds, I think. There, now that flashes. Now it's off. Almost got wet there. All right, now our coolant is off. I've got this down, that's why it's not moving right now. If I crank this up just a little bit, the table's starting to move. Yeah, you can hear it cutting. And here's the second spring pass, a lot quieter. There we go. So that was doing the exact same parameters. I didn't change the computer at all. Same program. And it's already doing a spring pass, finish pass, and then same again. And this second time around definitely cut some more. So we'll measure it up and we'll see where it stands. Beautiful. Measuring with the calipers, I'm measuring 0.3120 roughly, which is the same size as the bearing is exactly measured with an actual mic. So let's drop it in, see if it fits. I'm thinking it'll drop in, which is not exactly what I want. Yep. Drops in way too loose. Way too loose. Crapola. I shouldn't. Oh, why didn't I even test this the first time around? I should have just tried to put it in. I'm an idiot. Ah, stupid mistakes. Yeah, now it's stupidly loose. I mean, probably pretty darn accurate tolerances, but it certainly falls right in there. Thickness is good, though. Ah, crap. It was probably fine the first time. Idiot. I should have just put this in there and but I'm having a lot of fun this morning. I don't get to do a lot of R&D these days. Like, you guys have been watching Knifemaking Tuesdays for like 4 or 5 years now, and I used to get to do a lot of this stuff. Now it's mostly production based. We're trying to get these knives out. We are getting these knives out, and I'm too busy to film during production because I'm just making knives and we're just busting our butts trying to get everything out. It's really fun to come in on a Saturday morning, work on a new project, clear my brain a little bit, expand my knowledge, learn new things, and make these funny mistakes and share with you guys like I used to do way back in the day. I'm having a blast doing this. So I'm sitting here wasting time for a couple minutes trying to figure out, well, do I glue this one in or do I just make another one? Screw it, I'm just gonna make another one. I have the material, this is R&D. I have this one now, I know it's a couple thou big, I'm gonna write, or however big it is, I'm gonna write with Sharpie on it, slightly large, and then just make another one. I'll be done in like 5-10 minutes. Let's do it. Here's how I've got my material. I've just got these scrap L-shaped pieces of material, so just clamp it into these Carb Smart combo jaws, the grippy ones, and then I'm just gonna take maybe that end mill, manually come in and just go bzz, 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 chop it off, let this thing fall, and then hit go and let this guy turn into a beautiful part. So I'm gonna go into the MDI mode. I'm gonna go M3S5000 G43H7 to turn on the tool offset. Cycle start. It turns the spindle on. I'm gonna manually turn the coolant on. Jog in Y at kind of a medium speed. And then move to Z. I'm at 50 thou down right now. I'm gonna go to 100 thou, back to Y. Forward, I'm just manually cutting this piece off. Back to Z, from 100 down to clear it all the way. It's 156 material. Back to Y. And goodbye. Reset, open the door, admire my work. Who needs a manual machine when you have such a beauty? No, seriously, it is nice to be able to machine somewhat manually. Maybe that's, maybe that's the DIY side of me, the bootstrapper, the entrepreneur, the guy in his garage that's been doing this his own way. But I like that I can do this. I don't even have a bandsaw in this whole shop, but I have this. All right, back at it, making the next version. Right now it's doing that clearing pass where it's just kind of facing the outside. A lot of pointless air cutting in this. But there we go. So it's doing this swirly pattern around the outside now. I'm just taking the profile and I'm stepping it out and out and out. So it's cutting here, you can hear it, but it's not cutting out here, it's just air cutting. Wasted time, but who cares, because right now I'm not in this for the speed, I'm in this to get it done. Quick side note, I thought it was kind of funny. I was filming a quick video yesterday and I realized I'm still wearing my Tormac sweater. Even though I have now sold both my Tormac machines, I still have the surface grinder, which I really enjoy. I still have huge love for Tormac. I love this sweater. And this is my sweater that I wear at the shop most of the time anyway. So, this is not me trying to promote the Tormac brand anymore. It's just my sweater that I wear all the time at the shop that I still have. And I've been wearing for 4 years in all my videos. One day I'll get a new sweater, I'd like to. But right now I'd rather buy end mills. I don't buy clothes really. My jeans have holes in them and my shoes have holes in them, but I'd rather just get this shop humming. Back at it. Right now it is drilling all of those little through holes using a 59 thou drill. Very small drill. Beautifully quick tool change. And we're going to come in and clear out those holes where the bearings and the weights are going to go. Speaking of the weights, we'll have to make those today on the Nakamura AS200 LMYS. Got to get this bad boy turned on, swap out the collets, take this material out. So I got to make brass weights and I want to make those buttons today. Still got about 2.5 hours, I think, and should be able to do it. But I'm on Grimsmo time, which is like, you take what you think it's going to take and you times it by pi, and I still hope to get it done today. The weights are going to be easy. I've already made those before, so just put the bar in and hit go. The buttons I have not made yet, and they're kind of complicated threading, tolerances, and all that, so let's see. You know what's really fun, but also kind of scary at the same time? That's awesome. It's really hard to turn. The play in this bearing though, you lose so much speed when you rotate it like this. Like if I just keep turning, it stops. Those ceramic bearings, oh my gosh, they're gonna be awesome. They do have a little bit of play in them, but I mean, maybe you have to in order to have the tolerances not bind up at the slightest speck of dust or something like that. I don't know. These are some of the best bearings that I could find without spending $1 million. They're kind of expensive. You know, a cheap bearing, I think I spent $8 locally for these cheap ones. You can get them online for probably like $4. These ones are 18 from Boca Bearings. You can spend like 30, 40, 50, but I don't know if that's necessary. Whoa! Yes, I'm allergic to Falcor, Eric's shop dog. And he's hypoallergenic. Not working for me. And we're done. So in a perfect world for production, I would get these pieces water jet cut out of big plates of material, similar to how we have our knives cut out. So they'd end up looking kind of like this guy. You know, there's usually a taper on the wall, which is not ideal, rough finish, but do it as oversized, and then I can make a nice fixture and fit a lot of these guys in at the same time. Because doing it this way, it's fine for prototyping, but it's kind of silly for production, depending on how many I have to get to make. All right, so in CAD, I opened up, no, I made the hole a little bit tighter, and I didn't end up doing that second pass. And I'm able to push this guy in just with my fingertips. Look at that out. Oh, yes, baby. You know, I might want like a 1/10 or 2 tighter to actually need some more pressure to press it in. But that's pretty cool. That's an excellent start. Here you can see the difference that coolant makes if I turn the coolant off. I don't know if you can see close enough, but all those chips piling up, getting recut, no good at all. Not good for the tool, not good for the finish, not good for anything. Quick midstream shot. So I've faced what's going to be the top, and I've spotted the holes where the drill is going to go through now. You don't want to mess around with that tiny drill bit. You don't want it to walk off center. It's carbide, it'll just break itself. Now phase 2 of this project is how do I flip it over and cut out the top side and the outside and do all the work on the top as well. The first time I made these soft jaws, these Carve Smart soft jaws, which are awesome. And I put them in my vise, and I was gonna extend my vise to clamp down. And it worked okay, not great. The part didn't stay flat, even as much as I hammered it down. It kind of stayed crooked, both sideways and front to back. And it doesn't have a lot of grip, and these are aluminum, and they're gonna round out, and it's not gonna last very long. Now, I just realized a major flaw in what I'm trying to do, which I'm fixing in this model right now. So I bought these Mighty Bite XYZ expansion pins. These are awesome. I saw these in their catalog a little bit ago, and I really wanted to try them. And now I have the perfect job to do them in. Except the problem is, I forgot I turned on optional stop. Okay. So as you tighten, like this gets pressed into the fixture, and then as you tighten the screw, it's tapered, so it expands. So my thinking was I would go something like this, and then tighten the screw to expand it. However, there's no through hole. Dummy. So I couldn't even get an Allen key in there. So for the next one that I'm making right now, these holes will go all the way through the material, and then this should work really well. So I'm gonna sink these deep into the fixture in order to have the material just stick up like that. And these look like they fit in there quite nicely. Boom. So in classic Grimsmo fashion, I've run out of time. I did not even get to touch the lathe, unfortunately, but I was able to make several different variations, trying to get everything dialed in just perfect. These two should be good. And then I started to get these pins mounted on the fixture. I've got this Norseman blade fixture here that had some extra space, and it's repeatable on the machine, so I put both of those in there, and that's where I have to stop. We will pick this project up again very soon, very soon, next couple days, and see where it goes. Take care, guys. Later. Bye.